Imagine discovering something so massive, yet completely hidden from human eyes for centuries. This is the story of one of astronomy's most surprising finds. In 2010, the Fermi Gamma Ray Space Telescope was quietly going about its mission, scanning the sky for high-energy radiation that our eyes can't see. Scientists were conducting what seemed like routine analysis of gamma-ray data when they noticed something peculiar. Strange patterns were emerging in their data that didn't match anything they expected to see. At first, the team thought they were looking at a mistake. The data showed two enormous structures extending above and below our galaxy's center. It seemed too extraordinary to be real. But as they double and triple-checked their findings, the truth became impossible to ignore. They had discovered two colossal bubbles of gamma-ray energy, each stretching 25,000 light-years from the heart of our galaxy. For perspective, that's a quarter of the Milky Way's entire diameter. The scale was almost incomprehensible. Each bubble contains the equivalent space of 50,000 solar systems lined up end to end. When the discovery was announced, it sent shockwaves through the astronomical community. How could structures this enormous have remained hidden for so long? The answer lay in their invisible nature. The bubbles only emit gamma rays, the highest energy form of light, completely invisible to human eyes and most telescopes. It took the revolutionary technology of the Fermi telescope, designed specifically to detect gamma rays, to finally reveal these ghostly structures lurking in our cosmic backyard. Let's take a closer look at these enigmatic structures that have transformed our understanding of the Milky Way. The Fermi bubbles are remarkably symmetrical, rising like vast cosmic hourglasses above and below our galaxy's central bulge. Their nearly perfect alignment suggests they were created by a single powerful event. The temperature inside these bubbles is staggering. The gas within them is superheated to millions of degrees, making them shine brightly in gamma rays while remaining invisible to ordinary telescopes. To truly appreciate the Fermi bubbles, we need to understand their immense scale. Each bubble spans 25,000 light-years from top to bottom. That's so large that if you could see them with the naked eye, they would appear larger than the size of the full moon in our night sky. To put this in perspective, you could line up over 10 million solar systems inside just one of these bubbles. Their volume is so vast it defies ordinary comparison. The edges of the bubbles are particularly interesting. They emit an intense gamma-ray glow, suggesting they're being continually energized by powerful forces within our galaxy. The bubbles aren't just sitting still. They're moving at incredible speeds. The gas inside these structures is moving at up to 2 million miles per hour. This supersonic motion creates shock waves that help maintain the bubble's distinctive shape. The bubbles contain a mix of elements, including hydrogen, helium, and traces of heavier elements. This composition provides crucial clues about their origin and the processes that created them. As these massive structures push through the galaxy, they act like cosmic snowplows, sweeping up gas and dust in their path. This interaction creates complex patterns that astronomers are still working to understand. At the heart of our Milky Way lies a monster that might be responsible for creating the Fermi bubbles. Sagittarius A, our galaxy's supermassive black hole, contains the mass of 4 million suns packed into a space smaller than our solar system. Scientists believe that several million years ago, this cosmic giant underwent a feeding frenzy, devouring an enormous amount of gas and dust. Like an oversized cosmic belch, this event ejected massive amounts of energy and matter from the poles of the black hole. The evidence for this cataclysmic event is written in the stars themselves. X-ray observations reveal trails of superheated gas that appear to stream directly from Sagittarius A into the bases of the bubbles. These cosmic contrails are like smoke signals from an ancient explosion. The way the gas moves within the bubbles matches perfectly with computer models of black hole eruptions. The material flows outward at incredible speeds, exactly as we'd expect from a powerful black hole outburst. We see similar structures in other galaxies where supermassive black holes are currently active, giving us a window into what our own galaxy might have looked like millions of years ago. But perhaps the most compelling evidence comes from the bubbles themselves. The narrow stems of the bubbles, where they connect to the galaxy's center, point directly at Sagittarius A. Like massive cosmic fountains, they appear to have been ejected from a single central point. The chemical makeup of the bubbles also tells an interesting story. The materials found within them match what we'd expect to find near a supermassive black hole, including heavy elements that are typically forged in the intense conditions around these cosmic giants. Today, Sagittarius AI is relatively quiet, yet these bubbles remain as testament to its violent past, reminding us that even now, it could awaken again. While the black hole theory is compelling, several other fascinating explanations could account for these mysterious structures. Some astronomers suggest that intense star formation near the galaxy's center could have created the bubbles. When massive stars form in dense clusters, their combined stellar winds can create powerful outflows of gas and energy. These stellar winds, moving at millions of miles per hour, could have worked together like cosmic leaf blowers, pushing gas outward in both directions from the galactic plane. This star formation theory, known as the starburst model, has some intriguing evidence to support it. The chemical composition of the bubbles contains elements typically produced by massive stars. This includes specific isotopes that are created during stellar evolution and expelled in stellar winds. But what if the bubbles weren't created by a single event at all? Another theory suggests that the bubbles formed through multiple smaller eruptions over millions of years. Like a cosmic fountain that keeps spurting, each burst added more energy and material to the growing structures. Some scientists have identified what appear to be distinct layers within the bubbles, similar to tree rings, possibly recording different episodes of activity in our galaxy's history. Perhaps most dramatically, the bubbles might be scars from an ancient galactic collision. When galaxies merge, the resulting chaos can drive enormous amounts of gas toward their centers, triggering massive outflows. Each theory has its strengths, but also significant challenges to overcome. The starburst theory struggles to explain the bubble's remarkable symmetry. Star formation is typically more chaotic and wouldn't naturally produce such well-defined structures. The multiple eruption theory has trouble accounting for the bubble's uniform glow. If they formed over time, we might expect to see more variation in their energy distribution. As telescopes improve and new data emerges, these competing theories continue to evolve, reminding us that some of the most fascinating mysteries might be right in our cosmic backyard. The Fermi bubbles are more than just cosmic structures. They're time capsules, preserving the violent history of our galaxy. Like reading the layers of rock in the Grand Canyon, astronomers can study the different layers of gas within the bubbles. Each layer tells a story about what our galaxy was doing millions of years ago. The bubbles preserve evidence of massive energy releases from our galaxy's core, star formation bursts, and possibly even ancient galactic collisions. They're like a cosmic diary, recording events spanning millions of years. We've discovered that our galaxy isn't unique in having these structures. Similar bubbles have been found in other galaxies, suggesting that these explosive events might be a common phase in galactic evolution. The bubbles also act like a galactic weather system, influencing the space around them. As they push through space, the bubbles regulate star formation, distribute heavy elements, and help shape the magnetic fields that stretch throughout our galaxy. They're part of a vast cosmic recycling system, moving gas and energy between different regions of the galaxy, influencing how future stars and planets might form. Despite all we've learned, the Fermi bubbles still hold many secrets. Current research is trying to understand how the bubbles maintain their shape over millions of years, and why they continue to glow so brightly in gamma rays. The next generation of telescopes will peer deeper into these structures, potentially revealing new details about their formation and evolution. Understanding the Fermi bubbles isn't just about uncovering our galaxy's past, it's about predicting its future. By studying these structures, we're learning how galaxies breathe and evolve, helping us understand not just where we came from, but where we're heading in this vast cosmic dance. Thanks for joining us on this journey through one of astronomy's most fascinating discoveries. Remember to like and subscribe for more cosmic explorations, and let us know in the comments what space mystery you'd like us to investigate next.